it's a no-brainer to move towards an ARC powertrain. I'm Ryan Cook. I'm the co-founder and CTO of ARC, and I've been here since the beginning for the last 5.5 years building the best boats on the water.
My name is Karan Kaushik. I'm one of the senior systems engineers here at ARC, and I've been here for 2 years.
Our battery pack is large and quite heavy, so we have to design the vessel around the pack. But in many ways, that's more advantageous than in a gas boat. Our boat does not change weight as it burns through a battery. We throw a far more consistent wave through the range of the battery than a gas boat would. But also, because our pack is so large and heavy, we can actually fine-tune the center of gravity of the boat in a way that a gas boat cannot. We place the battery in exactly the right position to have the most efficient power levels through any speed of the boat. Whereas, again, in a gas boat, you can position the tank in order to try to do that, but depending on your fill levels, your center of gravity is going to shift around, and it won't be as efficient as an electric powertrain.
We have sensors everywhere on the boat, monitoring every single thing, including thermals, including power limits, as well as the state of the boat itself. So when you're riding or when you're surfing, the boat is constantly looking at everything and then making the right decisions that it needs to. All this is happening in such a closed loop fashion where any disturbance that comes in, it's already been taken care of before the person or before the user even realizes that it happened. The adjustments are essentially in real time. It feels super instant and it's always super responsive. You move slowly on the throttle curve, the boat will react the way it needs to. And if you instantly dump the throttle, you get what you want it for. Small micro movements of the throttle won't feel as jerky. Big movement immediately will give you the response that you're looking for.
If you were to send the maximum amount of torque through our propeller, the prop would spin in place and you wouldn't go anywhere. It's not like a tire on a road, it's a spinning propeller in water. When you spin up the propeller really fast and don't go anywhere, you do what's called cavitating the water. That's a physics limit. And so what we do is a lot of testing so that we can deliver you the fastest possible acceleration that physics allows by throttling the torque through the propeller in order to ride the physics cavitation limit to accelerate the boat as fast as physically possible.
The big brain is talking to every single thing, every single component on the boat. And what that allows us is to make this ecosystem that is smooth and controls everything. You tap one single button and it tells the brain of the boat, these are the ballast levels I want, and this is the side of the wake I need to surf on, and what speed it needs to run at. All that then translates into the brain then operating all the pumps and then instantly filling those ballast banks. Then all the user needs to do is just throttle up and pick a rider.
We do all of our testing in salt water. We undergo months-long qualification campaigns for every component of the system, but also the completed vessel in order to validate that it meets all of our design requirements.
Over time, your product will become more efficient, it will get more features and functionality, and it will also improve a lot on how it operates, and that instantly gets delivered to the customers using these OTA facilities. Over time, the boat that was delivered will eventually get better.